Welcome to Current Conversations. Today's current will be the Labrador current, and we will discuss its involvement in the sinking of the unsinkable Titanic ship. The science behind the sinking of Titanic has been quite controversial. However, hopefully this video will give you enough insight behind the mechanics of currents and oceans to help better visualize the disaster and why this particular current needs more attention. While it was a big hit in the box office, it took a big physical hit on April 14, 1912, when it hit an iceberg and went down with over 1,500 passengers on board. It was then known as the largest maritime in history. At the time, and for many years after, there was a lot of speculation around what caused the ship to sink. Plenty of books and research have addressed the question of how a ship that was so costly and so well built, quote, unsinkable, unquote, had such a tragic ending. Books such as What Really Sank the Titanic, New Forensic Discoveries, and Shadow Divers discuss potential sources of the crash. The theories vary widely, placing the blame on everything from incompetent sailors to flawed rivets. New studies recently emerged that focus more on biophysical causes of the crash. A researcher theorized that the alignment of the sun and moon created an illusion that hid the presence of the iceberg. In essence, the Earth had come unusually close to the sun and moon that winter, enhancing their gravitational pulls on the ocean and producing record-breaking tides. Another theory was summarized in a book written by Tim Malton that claims that the icy waters created ideal conditions for a strange illusion that hid icebergs from lookouts and confused a nearby ship about the location of the crash, delaying any rescue efforts by almost 4 hours. Malton studied the matter in detail and discovered that the boat ventured into the icy Labrador current that night and into a swarm of icebergs and ice sheets that are historically tailored for shipwrecks. Fog created in the region, most notably where the cold waters of the Labrador current meet the warm waters of the Gulf Stream, has also blinded and sealed the fate of many navigation vessels in the past. Before we continue, let's give a little background on the current and the ship itself for all the laymen out there, including myself. Let's be honest, this class has not been my friend. Labrador Current is one of several branches originating from the Gulf Stream, the best defined and strongest current in the North Atlantic. It is a surface oceanic current that originates at the Davis Strait, where it begins as a continuation of the West Greenland Current and the Baffin Island Current. From there, it flows southwards along the western side of the Labrador Sea. The current passes along the coast of Labrador, Newfoundland, and the east coast of Nova Scotia in Canada. The Labrador Current is a cold current with low salinity and reaches a maximum depth of around 2,000 feet. It carries a volume of water ranging between 125 million and 190 million cubic feet and transport numerous icebergs southward. It is not the strongest, largest, or fastest current in the world. Part of the reason for the low velocity is the atmospheric low-pressure system situated over Baffin Bay and to the south of the Kalalit Nunat, known as the Icelandic Low. As the Labrador Current is flowing south, away from the low-pressure system, it is working against the atmospheric pressure gradient, and this can be represented by the North Atlantic Oscillation Process, also known as the NAO. A positive NAO phase, strong pressure gradient, results in stronger northeasterly winds blowing in onto the shore and a weakening of the Labrador Current. It is important for many reasons, including environmental and societal. It is linked to the global ocean current system, which in turn is linked to atmospheric systems and climate. Influences the fishery-dependent communities of Newfoundland and Labrador, and the effect of climate change on the Labrador Current creates changes in the climate of the coastal communities and in marine habitats. Thus, it serves as an example of an effect on the human environment resulting from a change in the physical environment. At the time it was built, the Titanic was breaking boundaries as the most luxurious and fastest ship in the world. It was marketed as unsinkable and attracted visitors and customers from all over the world. It was almost 900 feet long and reached 100 feet in height. It needed 170 men to shovel coal into its furnace, which then proceeded to burn 600 tons of coal per day. The ship screamed extravagance as millionaires piled on, looking to take advantage of the Ritz-esque facilities like the Turkish bath, gym, pool, and squash court. It even had its own personalized newspaper, the Atlantic Daily Bulletin. The ship was built with 16 compartments below sea level. It was structured in a way that even if the 4 forward compartments were flooded, the boat could still function accordingly. Unfortunately, almost all 16 of the compartments were obstructed by the iceberg, which caused them to be filled with water. All the extra weight pulled the Titanic into the water. The extra weight caused the ship to tip over, leaving one side completely submerged and the other above water. Then, snap, it tore into two pieces. One half sunk to the bottom of the ocean, while the other pivoted above water for a short while before following the first half's lead. Hours later, when rescue came, only roughly 700 passengers out of thousands had been saved, most of whom were first-class women and children. Now let's piece together the two factors. The Labrador Current has a tendency to sometimes go farther south and or east than normal. This can produce hazardous shipping conditions, for it can carry icebergs into an area of the Atlantic where they're not usually found. A cold current flows down from the North Pole and down around the coast of the Canadian province of Newfoundland and Labrador, where it meets up with the Gulf Stream. The icebergs encountered in the North Atlantic originate from the western coast of Greenland, where glaciers deliver large quantities of ice. Every year, tens of thousands of chunks of ice drop from the front of the calving glaciers into the sea. The wind then pushes the icebergs away from the coast into the West Greenland Current. This marine current transports the ice slowly north, far away from ship routes. They drift northward up the coast until they meet the Labrador, then ride south in huge masses toward Newfoundland. Nowhere else in the world does this much ice intersect major shipping routes. The region deserves its nickname, Iceberg Alley. Icebergs, fog, severe storms, and ocean traffic make Iceberg Alley one of the world's most dangerous shipping areas. Temperature differences between the Labrador Current and the Gulf Stream add up to 20 degrees and produce dense fog and unsteady seas. Let's go a little more in depth. After icebergs separate from the glaciers in West Greenland, they usually drift northward into Baffin Bay. They then turn to the south and move along the Baffin Island coast. Floating around, they continue their journey southward into the cold waters of the Labrador Current. Near Newfoundland, there are two branches of the Labrador Current. There is the inshore branch and then the offshore branch. The inshore branch flows southward near Newfoundland's east coast near St. John, and sometimes carries many icebergs, which creates excellent opportunities to view them from the shore. When the icebergs pass Cape Race, the southeasternmost point of Newfoundland, they usually turn into the west and move south of Newfoundland. Icebergs traveling in the inshore branch rarely pass south of 45 north. The offshore branch in the more powerful of the two branches of the Labrador Current. Similar to the inshore branch, it flows southward except along the eastern edge of the Grand Banks. It moves the icebergs toward the much warmer waters of the Gulf Stream. When icebergs encounter the warm temperatures in the vicinity of the Gulf Stream, they usually melt very rapidly. Some icebergs survive long enough to travel extraordinary distances to the south. The cold waters of the Labrador Current commonly support icebergs as far as 41 degrees north latitude. So the main takeaway is that it is the Labrador Current that carries an iceberg southward into the Gulf Stream. Unfortunately, in 1912, the icebergs were feeling particularly ambitious and crossed into areas frequented by ships, namely the Titanic. That year, there was an excessive amount of icebergs flowing in the shipping stream, the highest number since 1904. In the wake of the Titanic disaster, the International Convention for the Safety of Life at Sea, also known as SOLAS, created the International Ice Patrol, the IIP, in 1913. SOLAS mandated a 24-hour radio watch, boats, drills, and lifeboats for all passengers on ships navigating the Iceberg Alley. The IIP's mission remained to monitor the extent of the iceberg danger near the Grand Banks of Newfoundland during the ice season and broadcast the location of the southeastern, southern, and southwestern limits of all known ice to interested shipping. Following the Titanic disaster, double-sided hulls were added to the ships to prevent minor hull punctures from causing major damage. Also, the watertight compartments were raised to a higher level so that water could not spill over the tops if the ship were hit at a low angle. New safety regulations were established after the sinking. Some examples would be the mandatory use of the wireless for large ships, the minimum lifeboat capacity equal to the number of passengers and crew aboard, and the implementation of the ice patrol to warn ships of nearby ice fields. The Labrador Current plays a major role in influencing the climate of the Canadian provinces lying along its path. History and global politics makes the North Atlantic especially sensitive to the movements of icebergs. The North Atlantic has been a vital part of the international economic, political, and security system for many years. These shipping lanes are very important since the US, the Canadian East Coast, and Western Europe are powerhouses of the world economy, and it is a tie between all three. The Titanic left a large impact and will never be forgotten. It is being commemorated in pop culture as well as science culture. It changed shipbuilding and sea safety, but most importantly, it pushed scientists and oceanographers to extensively dissect ocean circulation, particularly what's happening. It will be immortalized in the stories of many and will continue to push researchers to study the current and hopefully climate change simultaneously. Due to the mixing of varying temperatures between the Gulf Stream and the Labrador Current and the low temperatures and salinities of the current, we can expect to see many more icebergs headed toward popular shipping routes. In order to avoid a similar tragedy, patrolling around the area, as well as research on climate change prevention and iceberg maintenance, need to be extensive. Thank you for tuning in to Current Conversations.